Thank you, everybody, for coming to the North Andover Historical Society's Worden Theatre this evening. My name is Joanna Kerr, and I'm the Executive Director of the North Andover Historical Society. Welcome here to the Stevens Centre on the beautiful Common here in town. We're so glad you joined us this evening for Electrify Your Home. This is a collaboration between North Parish Church, Climate Justice Group, the North Andover Historical Society, and Heat Smart Alliance. Our speakers tonight are Chris Spychalski and Gary Martin of the Heat Smart Alliance. They will cover information about converting your home to an electric HVAC system using either air or water source heat pumps. I'll just introduce our speakers this evening. Now, Gary Martin has degrees in electrical and mechanical engineering. He has long been interested in environmental and climate issues and is on the board of the Massachusetts Nature Conservancy. He's a member of the North Parish Climate Justice Group, chair of the Boxford Sustainability Committee, and more recently he joined the Heat Smart Alliance, whose mission it is to reduce greenhouse gas emissions by accelerating the adoption of energy-efficient heat pumps. Chris is a comfort consultant at Comfort Craftsman Mechanical. Chris volunteers with the Heat Smart Alliance and electric vehicle groups. He is motivated to displace fossil fuels so people can spend less, pollute less, and enjoy a healthier environment. He and his wife and daughter and dog live on Barker Street here in town. The electric bug hit him around 2012, and their home became net zero positive in 2018 and had with zero emissions in 2022. Just to let you know, the Stevens Centre here on the Common, owned by the North Andover Historical Society, has also just been awarded our second net zero certificate for 2023. This Worden Theatre is powered by the sun, with solar panels on the roof, and we also have a geothermal system for heating and cooling. There's a lot happening in this building. We hope you'll check out our Child's Play exhibit and history wing, and the 1646 bookstore for a selection of books and gifts. Diane's Cafe on the Common, while it's not open right now, is a welcoming spot for coffee and delicious pastries, breakfast and lunch. Both the museum and the cafe are open Wednesday through Sunday from 8 o'clock until 2 p.m. I'd like to tell you that we have a lot of exciting programs here at the Stevens Centre. We have a great partnership with the Acting Out Theatre Company in Lawrence, and we're working on a series of Saturday afternoon theatre readings called All the World's a Stage. No non-profit can function without members and volunteers, as the North Parish Church will also tell you. If you like what we're doing here at the North Andover Historical Society and at North Parish, we welcome volunteers and we welcome lots of interest in some of the amazing things that are going on in both of our neighbourhood properties. I'd like to remind everybody of our safety and courtesy considerations just before we get started. Please put your cell phones and other noisemakers on silent mode during the program. Please refrain from drinking or eating anything other than water. The bathrooms are just through the boardroom and on the right-hand side. And in case of emergency, there are two exits. The first one is the one you came in, and the second one is out here on my left. Many thanks to Chris, Gary, North Andover Cam. This is being filmed for future watching on YouTube, and the North Parish Climate Justice Group for making this event possible. I'll first introduce you to Gary Martin. Thank you.
Thank you. Find my notes. Get started. I'm a member of the Heat Smart Alliance, but I also wanted to recognize the Green Energy Consumers Alliance which I am using some slides that I got from them that they used in a webinar earlier this year. The first step in electrifying your home is to make sure that air leaks are sealed and the home is very well insulated. Mass Save will pay for much of the cost of doing this, and many older homes could cut their energy loss and the cost of heating them by half or even more. Making your home more energy efficient will save money and reduce emissions both before and after electrification. Oops, wrong way. Improving energy efficiency allows new HVAC, which stands for heating, ventilation, and air conditioning, systems to be smaller and less costly. We will be focusing on the heat pumps in an HVAC system, but electrification could also include passive solar hot water. Let's see. And in this slide, there is a solar collector on the roof that's sending hot water down to a hot water tank. There are also heat pump hot water heaters. Induction stoves in case you have a fossil fuel burning stove, a heat pump dryer, an electric car, and solar panels on the roof which could power everything. Finally, if your roof is not appropriate for solar, you could consider buying clean energy and reducing your electric bill through a power purchase agreement with a local community solar company. First, what is a heat pump? Well, a heat pump does not generate heat by burning something, but instead it moves heat from a colder place to a warmer place, which is what air conditioners and refrigerators do. This is analogous to a water pump, which does not make water, but it can move water from a lower place to a higher place. I'm not going to talk about the illustration on the right, which shows how a heat pump works, but you could talk to me afterwards if you're interested in that. But instead, I just want to point out that there are many types of heat pumps that vary in efficiency and cost. The heat can come from either the outside air or from groundwater. And the air source heat pumps work even when it's very cold, down to at least minus 13 degrees Fahrenheit. In either case, the heat can be moved into a forced hot air or a forced hot water system. And the process can be reversed so that heat pumps can be used for both heating and cooling. And finally, you can have either one large heat pump that serves the whole house, or you can have multiple smaller heat pumps. And I will show some examples of air source and ground source heat pumps for forced hot air systems. And following my presentation, Chris will be talking about a forced hot water system using heat pumps. Okay. First, here is a central air system with a large outdoor unit which captures heat from the outside air. And, oops, did I go too far? How do we get back? Going the wrong direction. I don't know what I did.
I think you're going to the right arrow, go to the left arrow to go back.
Okay, let me go to the left arrow. I think that's, okay. I think this is where I am meant to be. This is a ducted whole home heat pump, which has an outdoor unit that looks like a central air conditioning unit, and an indoor air handler, which receives the heat captured by the outdoor unit and transfers it to hot air, which is blown through ducts into the house, and then that air is returned to the indoor unit to get more heat and continues to circulate. A ground source heat pump operates in much the same way, except there's no outdoor unit. Instead, there is a closed loop pipe for circulating water into the ground and back out. The water that's circulated and comes out of the ground is near the temperature of the groundwater, which is always close to 40 or 50 degrees Fahrenheit. That goes into an indoor unit, which has the components of both the indoor and outdoor units of an air source heat pump. And it extracts heat from the water that's being circulated and transfers that heat into air, and like in the air source example, that air is blown into your house for heating. Note that when the heat is removed from the water that comes from the ground, the circulating water drops in temperature by a few degrees, and it's pumped back into the ground where it absorbs more heat and continues to operate. Okay. Now, let's see if I go the right direction. Okay. Okay, this is a ground source heat. That's not where I meant to be. Let me go back. This is where I meant to be. Okay, if your house does not have heating ducts, it may be appropriate to use ductless heat pump, or often called mini splits. And the mini splits have a variety of different indoor units that blow air directly into the room rather than through ducts. And these indoor units are connected to outdoor units that capture heat from the outdoor air. These outdoor units need a free flow of air in order to do that transfer of heat from the air. And they must be off the ground to prevent ice buildup. In this picture, you can see the refrigerant lines that are covered that go into the house and connect to the indoor units, go into and come back out. It's a circulation. And each outdoor unit can be paired with one or more indoor units. All right. Comparing ground source and air source heat pumps, the ground source, and I want to put both up, ground source unit is more expensive, but there are larger incentives to pay for it. A ground source unit is more efficient to operate because it transfers heat from or to the near constant temperature groundwater rather than from the outdoor air, which at times can be very cold or very hot. An air source system is cheaper and easier to install, but it is less efficient and requires some outdoor space for capturing the heat from outdoors. Okay. And how much will it cost? For an air source heat pump, and for both of these, I only have rough estimates. The cost varies a lot from one house to another, depending on how large the house is and how easy or difficult it is to make the addition. But you should expect that for one indoor and one outdoor unit combination for an air source heat pump, for mini splits, it would be something like $6,000 to as much as $10,000. And if you have outdoor units that connect to multiple indoor units, the cost per indoor unit would be less. For a centrally ducted air source heat pump, the cost would be something like $15,000 to $25,000, or even more if you have a large house. But skipping a bullet, the cost in either case should be comparable to a fossil fuel heating system with a separate central air conditioning system. The heat pumps have the advantage that it's one system that does both rather than having to buy two different systems. You'll likely need 20 amp electric service, and if you don't already have that in your house, that would be an additional expense. But on the positive side, there are incentives that can offset much of your installation cost. For a ground source heat pump installation, again, the costs vary widely depending on how easy it is to drill wells and the size of the system. But it should be something like $50,000, but it could be less than that or more for a large house where it's difficult to drill wells. Again, 200 amp electric service is needed. But on the positive side, there are even larger incentives that can offset much of the installation cost. In Massachusetts, through Mass Save, they will provide incentives up to $15,000 for ground source heat pumps and $10,000 for an air source heat pump. Additionally, a heat loan of up to $50,000 is available at 0% interest for 7 years, and that can also be used for any cost of electrical panel upgrade that's needed. On the federal side, there's 30% tax credits available for a ground source heat pump, and smaller incentive for air source heat pump. The operating cost, there's several variables involved, but the one point I want to emphasize again is that weatherizing your home is very important to reduce the amount of heat or cooling that you need, so you're not using them as much. The thermostat settings will have an impact as well. In Massachusetts, the standard cost for electricity through utilities is very high, but even so, ground source heat pumps are generally the lowest cost to operate of any possible source. Air source heat pumps are not as sufficient as ground source heat pumps, so oftentimes they cost more to operate than an efficient gas system. But it all depends on the electric cost. And oil and propane heating systems are the most expensive to operate. To reduce the electricity cost, you could join a municipal electric aggregation if that's available in your town. That'll provide some cost reduction. Community solar would generally allow you even somewhat lower energy electric costs than municipal aggregation. And if you have a home that is suitable, having your own solar panels, which will be producing free electricity, is certainly the cheapest way to go and makes the any heat pump least expensive. But besides those costs, we should consider the environmental cost of these systems. And the heat pumps, which operate on electricity, produce far fewer emissions than fossil fuel-based HVAC systems. And that's based on the current Massachusetts electrical grid, which generates roughly half of its electricity by burning fossil fuels. In the future, state law requires that the utilities burn less and less fossil fuels and generate more and more clean energy. And, whoops, went further than I wanted to go. Heat pumps emissions will tend towards zero as the grid approaches 100% renewable electricity, and that's the goal within the next decade or so to come close to or reach that. Another benefit of heat pumps is they don't use gas that can explode, and we've seen that happen in the Merrimack Valley. And if you can remove gas from your home, that's nice. They can also improve indoor air quality because fossil fuels have emissions that when they're burned within the house, and that's nice to get rid of as well. Oh, okay. I'm planning to skip over the last few slides, but if anyone's interested, I could talk to you about that. But it's about when to do it, and you could look into having a heat pump coach help you in navigating all the different possibilities of how you could electrify your home or transition to heat pumps. And there's 3 possibilities here. Mass Save offers no-cost consultation. The Heat Smart Alliance has volunteer coaches, and the Green Energy Consumers Alliance also can provide help in installer recommendations and fairly low-cost paid consultations through their partner, Abode, if you're interested in that. Thank you. Yes. Thank you. Chris, I'll leave it to you to find where.
All right, sounds good. Thanks, Gary.
Let me help with that keyboard. I think the keyboard's actually coming in and out. And
That's my
probably
first
the
slide.
problem. So if you do want to use that one, use these instead, if that's okay. Yeah, use
Okay.
these. This thing keeps going in and out. I think that was originally the problem.
All right.
If you wouldn't mind putting that behind you, just in case. Thank you so much.
Okay. So my name's Chris Spychalski, and I'm a volunteer with the Heat Smart Alliance. They've got a .org website, as you can see. I also work at Comfort Craftsman to install heat pump equipment. So this is a story about my house. In 2018, this was our starting point. This boiler is from 1989 when the house was built. You can notice all the ductwork for exhaust and also a fresh air vent that I just kind of hacked and put in there. This needs a lot of air to operate. At this time we had a heat pump water heater and water baseboards with this one having the cover off. Does anyone live in a house with water baseboards? If you could just raise your hand for me. So Yeah, it looks like maybe a third or more. All right, so it's something that's hopefully familiar to you. As Gary mentioned, there's what I like to say 4 kinds of heat pumps, and you can differentiate them by the source of the heat and then how the heat is distributed. So air or water for the source. Most of the advertising we see is about these, mini splits. Air to water is one of the specialties of Comfort Craftsman, and also geothermal, which would be a water to air or water to water. And combinations are possible also. Before I started this job with Comfort Craftsman Mechanical, and as a homeowner, I had to interview a bunch of HVAC contractors. So one thing that became apparent is if somebody can only install mini splits, they'll give you reasons not to pick one of the other types. So you need to be smart enough to figure out, hey, is this biased advice? Can I talk to somebody that can guide me through all different kinds, or at least, like you said earlier, work with a coach that can help you out with that. Another message here would be that this is complicated, so if you're in a position to do your research before something's broken, you're in a much better position to figure out what you really want. This is a fairly busy slide, but it's the first step that a good HVAC contractor should take in analyzing what size of equipment you need. This is called a manual J. It's basically how much heat does your house need to be at 70 degrees or maybe 68 in the wintertime. For my house, you could see it's in the mid 30,000s. It's about a 3,000 square foot house. And in our neighborhood here, 9 degrees is our coldest day in the winter that we're trying to plan for. So we're trying to move enough heat from outside at 9 degrees so everybody's happy at 70 degrees indoors. And then there's a room by room breakdown. That's like a next step. You can do this as a whole home or as a individual room heat load. And that is something I needed when considering an air to water heat pump, because each room has its own baseboard radiator. One thing to note is this family room, that needs a lot of heat. It's maybe 1/3 of the total. So we'll just keep that in mind for later. So when analyzing if an air to water heat pump would work to reuse our existing water baseboards, we need to know, well, at the air to water heat pump output temperature, is enough heat going to be distributed to each of these rooms? And the air to water heat pump that was available at the time had a maximum output temperature of 130 Fahrenheit water compared to the natural gas boiler it was replacing, which is 180. So it's not nearly as hot in terms of the water that's being output. So we consulted with a person who's leading in this hydronics industry. It's got, air to water's got this funny name, hydronics. But John Siegenthaler helped out by analyzing at the 120 Fahrenheit output, how many BTUs are going into each room. And it was just that one, big room I mentioned earlier that didn't have enough baseboard length to output enough heat into the room. So does that mean you just give up on the air to water heat pump? Well, maybe, but for our house, a wood stove happens to be a great hobby. I've enjoyed burning firewood and making it. So it's just a matter of having a secondary source of heat. So if the baseboard can't keep up in that one room, I'm happy to use a wood stove. Somebody else might want to use a space heater. We could install more baseboard or low temperature radiators. So the water baseboard from 1989, that's high temperature, that's 180 Fahrenheit. In Europe, it's very common to see a low temperature water radiator that would put out enough heat into this one room. So there's a few different choices in terms of how to make the need of the room match the output of the heating distribution. So here we are in August, comparing this to the previous picture of the mechanical room. We still have the same heat pump water heater, and we have new air-to-water heat pump equipment. Basically, the refrigerant line from outside comes in here and exchanges heat into this 80-gallon water tank that distributes heat into 4 different zones for the house. You can see the 4 control zones here. One nice arrangement is with all this copper, the hot water, it's 120 or maybe 130 Fahrenheit water that's going through these. It just makes the room really warm. And that's a nice source of heat for the hot water heater. Let's see here. Yeah. So I'm going to switch gears a little bit and let's take a look at the electricity, the electricity loads that this equipment needs will vary based on how cold it is outside. So here it's 20 degrees outside, and here's the signature of the whole house. Every load, every electrical need in the house is sort of peaking this way, but because the heat pump itself is such a big load, there's very little going on in the house at 1 a.m. So you can see a big spike for the heat pump to operate to make it warm inside when it's 20 Fahrenheit outside. We had a polar vortex, I don't know what you want to call it, in February of 2023, probably all remember. It got down as low as -12. Our design temperature, if you remember, is 9 Fahrenheit, so this is quite a bit colder than we're designing for. But you can see the difference in peaks here. The other thing to note about this polar vortex event, there was a lot of wind, and that'll just suck the heat right out of your house. So the heat pump's really having to work pretty hard there. Again, looking at some of these colder events, this heating season, we were able to install a software upgrade to the air-to-water heat pump, which does a better job of looking at outdoor temperature and saying, well, how much heat needs to go into that white tank to make all the rooms comfortable? So if it's 15 degrees outside, the tank needs to be 125, and I think that pretty much proves some of the HVAC contractors that say, well, you just can't do that with old water radiators. Well, yes, we can. So here's on the heat pump itself. You can see that when it's 24 degrees outside, the tank needs to be at 124, but when it's warmer, when it's 55, the tank only needs to be at, that looks like 90 to me from this angle. But you save a lot of electricity, you save a lot of money not having to buy as much electricity when you're trying to make your tank 90 degrees. It's just a much easier lift for the pump to go from 55 outside to 90. So that's a nice feature of the new software. And again, just taking a look at the electric load signatures from 2 in the morning. You can zoom in on this one peak at 3 in the morning and see if we zoom in on a 15-minute time period. This is kind of what it looks like. Switching gears over to a battery system. We have two batteries that total 27 kilowatts. So that's basically how much electricity you can store. So if you're using 1 kilowatt hour per hour, then it'll last for 27 hours. And here we have a not so sunny day. So the solar is what's charging the battery. And it wasn't very sunny on this particular day. So we only got up to, maybe this is 70% full on the battery. And of course, at nighttime, the battery is being used instead of the grid, down to a level of about 20%. And then on the next day, there was a lot of sun. So you go from that overnight of 20 to back up to 100, and we're not using, grid energy. We're actually doing better. We're exporting it when you see this purple area down below the horizontal line. You're getting paid to sell your electricity to the grid through a process called net metering. And in Massachusetts, it's a very good rate. We're in a great state for that. So if you wanted to compare last year to this year's April, and with the idea of self-consumption, you can kind of get a sense for that here and here. I'm going through this kind of fast because I know there's a YouTube recording, and if you're really that interested, you can go back and look at the recording or get in touch with me. We can spend a long time talking about it. Here's another busy slide. What I'm trying to show here is in the summertime, you produce a lot of solar electricity. Here's another summertime. And in the winter, you produce very little and you use more. So that's why the red line's below the horizon there. In the blue, this is the net metering electric utility balance. So since 2018, it was always under zero, which means we had this credit. And over time, we didn't have to pay electricity since 2018. But then in this year, we sort of used up our credit, and we might be, net zero, like averaging out all the months of the year. We'll see where we end up at in December of this year if we can say that, hey, we're still net positive, net negative. It doesn't matter so much. I'm just really happy to be off of gas and paying for that, and I'd much rather pay an electric bill if I have to. But these are the first months that we had to pay an electric bill from our checking account. So it lasted for a good long while. The process that Gary mentioned of air sealing and insulation, called weatherization, you're never really done with it. You might have new weather stripping on your doors and windows, but maybe they last 3 years. So you got to go back and stop those air leaks and put on new weather stripping. Here's an example of a window that wasn't installed properly by, I don't know who, but we were moving into the house in 2008. So somebody before us hired this window contractor, and it's hard to see, but there's a little gap on the molding here. A thermal camera can sense temperature differences. So here on the scale, you can see where it's kind of warm and then where it's pretty darn cold. That particular area is letting in a lot of cold. So it's really not the window itself. These are just really average double paned windows. It's the installation job that is really horrible and letting in a lot of cold. So in theory, you can go through the rest of your house and see, all these dark blue areas and fix them with different techniques. One area in our house in the basement had 3 single pane windows that you've probably seen before. And instead of taking on the full expense of removing those and putting in double pane, there's a couple of companies that sell interior storm windows. So you pretty much put in this extra pane, the second pane of glass around the whole opening for the window in the basement. And that was a lot more cost effective. These folks are in Connecticut. There's another one further out west, I'm sure you can find on the internet. And here's a list that, again, if you're that motivated, you can look at all the stuff we've done in terms of converting from fossil fuels to electric. It's been a really, just all of this equipment is just better. So, ask me or look at the recording. Now we're switching gears again to geothermal with a price example of the rebates that Gary mentioned earlier. If you have the right kind of home that you're comparing air to water to geothermal, you can definitely say that the first year cost, the gross cost for geothermal on one of the Comfort Craftsman jobs we quoted is 139 and change before the rebates. And that is higher than the air to water for the same house and needed 2 air to water heat pumps. But when you compare the net cost, that's the trick, is to not get frightened by the gross cost. You have to net out the rebates. You can see the net cost for geothermal is actually substantially less. And then you get the benefit of less maintenance. You're paying less for the electricity to run the geothermal system. So there's a real world example for you. And in a large home in Saugus, we used multiple geothermal heat pumps to take care of this home's needs, space heating and cooling, domestic hot water, and they also happen to have a pool. Another popular choice for the extra heat pump is never having to deal with snow again on your driveway. I mentioned the Comfort Craftsman website at the beginning. If you want to request an appointment and have, personal service, have your own home evaluated, there's a easy way to request an appointment. And like Gary, I have a few extra slides if we want to get into them, but I think we're both looking forward to your questions and making this interactive. Okay.
Well, thanks to Gary and Chris for their presentations, and it's wonderful to get people thinking about what they can do to electrify their homes, as Chris said, before something breaks. So thanks. In just a minute, Gary and Chris will take questions. But first, my name is Karen Martin, and I lead the climate justice group at the North Parish Church across the street. Our group acts on climate justice issues by educating ourselves and our community on clean energy, like this presentation tonight. You may have attended our other recent event on network geothermal energy for heating as a way for utilities to provide thermal heat and retire the gas system. That's kind of what we're all about, is getting rid of gas and turning our houses into electrified ones. We also advocate for Massachusetts legislation that would promote that. And we occasionally host rallies, which you might have noticed this morning if you drove through the old center. So if you'd like to know more about what we do, you could email us at climatejustice@northparish.org. And if you'd like to join in with any of the legislative advocacy. We're fortunate tonight to have Lauren Craik of All In Energy with us. All In Energy is a nonprofit that has partnered with the town of North Andover, as well as some other local towns and cities, to promote mass save energy savings programs, which will provide no-cost home energy assessments and great incentives for improving home energy efficiency to save money. She'll be set up right out side here and can help you get started on making your home more energy efficient and find the next steps to electrify. So thank you all for attending the Electrify Your Home event this evening, and thank you to the North Andover Historical Society for partnering with us and allowing us to use this great space. And as has been alluded to before, the presentation will be on YouTube, the North Andover CAM YouTube site, and hopefully we'll get to send that link out to you later on. So, time for questions.
I saw that there was also radiators next to the baseboard. The system that you were talking about, Chris, can you use that with old radiators? Because
Yes.
I was told I'd have to take out all my radiators and blah, 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 blah.
Well, it depends is the honest answer. So again, we're trying to first confirm with math that the radiators at a lower temperature will give each room enough heat. So if you only have one radiator in your house, well, that probably wouldn't work. But if you have enough, it could work. One exception would be steam. If they're steam radiators, that would not. If they're water radiators, which we can evaluate and tell you which kind they are if you don't know already. But yeah, there's a chance that they could be work, or you could add some extra heat, supplemental heat, to make the system work.
Okay, thank you.
Is there one system that is better at controlling humidity? I mean, most houses here in the wintertime are drier than the Sahara Desert. And health-wise, it's more beneficial to have a little humidity in the house.
So there's
factored in.
Yeah, so the question's about humidity and system choice. Well, there's two times where you want to consider humidity levels. In the winter when it's really dry, like the gentleman said, or also in the summer when it's really moist. So for the winter time, if you have ductwork already, we can add a humidifier into that system and monitors so we can distribute our humidity to the right level. We can see if your home right now without extra humidification is at 35, and we can bring it up to a more comfortable 50. In the summertime when it's too humid, refrigerant-based systems have trouble removing that humidity. They don't remove it as well as a water-based or hydronic system. So there's a way to have a hydronic air handler. Because of the way things work, you're able to pull more moisture out of your home's air by using a hydronic equipment in your ductwork. And that's kind of the hidden secret around hydronic cooling, is that it can take more humidity out than a refrigerant-based system. The trouble is you might think that you have to install big sheet metal ducts to make it happen. There is that possibility, so if you have an unfinished basement, you can install new ductwork without any restrictions on the sizing. But if you're looking at a renovation with just closet space, going between floors, for example, then there's this kind of ductwork, which has a little hole, but basically is a lot less disruptive and a lot easier to install. So it's something to consider if the budget allows. So it takes individual analysis to see if the layout's good, if hydronic cooling is an option. But if you can find a way to use water-based hydronic cooling, that will remove more humidity in the summertime.
Thank you.
Thanks for the question.
I have a couple questions for both of you. How long have you both been doing this, or
Well, I don't install HVAC systems. I have looked into them for, I don't know, 15 years or so, because we, someone like Chris, have converted our house to all electric, and we have a ground source system that is partially ground source to air and partially ground source to water. But I know about systems from how they work and what's involved, but I haven't worked in actual installations and don't know the details as much as Chris does.
As a homeowner, I guess for a really long time, but as somebody who really wants to feel like I'm doing something to combat climate change issues, for me that started around 2012. It got a lot more focused in 2018 when installing the heating system, and then the company that I worked with, Comfort Craftsman, the owner's been doing this since he was, I think he installed his first boiler when he was 19. So he's really the one with all the experience. There's a lot of stories I could tell one off. He's been in this a long time.
why do you guys advocate for climate justice?
Well, if you love the world and the people in it, you want to do something to prevent what could happen if we don't do something to change what has been happening in the last few decades.
There's a bunch of reasons for me. I guess I have a daughter, and just also care for being optimistic about the future and trying to do something about it. If you're trying to leave a legacy, you want to try to say, hey, you made things better. But also it just can quite simply come down to saving money. Like if you look at the total cost of something over 10 years, not just year one, the cost to buy it, the cost to maintain it, the cost to operate it, electric cars just win. And they're a better car, in my opinion. So, things like that can happen where it's, a clear financial benefit. Electric chainsaw would be another great example. But it's just once you experience a little bit of it, you just want more of that kind of improvement.
Can you speak to your energy costs now versus before 2018 when you were heating with fossil fuels on an annual basis? I realize there are variables, but can you speak in general?
So when doing that quite busy slide with the whole house heat load, for 3 years the only natural gas appliance we had was the natural gas furnace. Boiler. So we had 3 years of let's say roughly $1,200 per year for gas. If I end up in the future paying roughly $1,500 a year for electricity instead because of the air to water heat pump, then I feel like I'm breaking even. That's an oversimplified, for somebody who likes to run spreadsheets, I'm like, I can't answer that because I don't know the end detail, But generally, broadly speaking, I would much rather have a house with no gas at all because I don't have to worry about the Merrimack Valley explosion problem. I don't know how to model that financial, but that's kind of the tipping point. That once that happens, it's like I don't want to bear that cost. I'd much rather have a monthly price for electricity, which we just really even haven't experienced yet, but it might be coming in 2024 or something. But if you want to talk further offline, then we can get into details.
Have you also incorporated passive solar?
Solar panels for electricity?
Yes.
Yeah, there's a 12 kilowatt array on the roof.
Okay.
Each panel's got roughly 305 watts. when they're brand new and in the laboratory. Nowadays, you can get 410 watt panels in the same space. So that's about a 50% increase on our whole array, which would be wonderful. I just wish, it didn't cost money to switch things out. I'd be happy to export more electricity to the grid, and all that is clean, renewable energy. Gentleman behind you there?
Me?
Yeah, sure.
So, our gas furnace is actually in the attic. And I'm wondering, the house was built in the mid-1980s, I think, and which we thought was a little unusual, but I don't know if that was a common thing at that time. But is that bring any additional challenges to putting in one of these heating systems? The ductwork maybe would be, it might have to be changed, I guess, significantly.
Okay, I'm having a little trouble hearing you, but from what I heard, your gas furnace is in the attic.
Right.
And is the attic vented attic, like a cold attic, or is it a hot attic where it's been foamed and sealed in?
No, it's a cold attic.
Okay.
We actually had Mass Save come in, and they did a nice job with the insulation on the top between the rafters.
So that's like on the ceiling of the house?
Yeah.
That's not on the ceiling of the
Right.
roof?
It's not on the
Yeah,
peak of the roof.
so that's the difference that would, if you can convert your attic into a hot attic, so the foam is on the opposite side of the shingles,
Yeah,
right? That would help a lot. Having your ductwork in a cold attic is horrible for the winter. There's two components to a good functioning system.
mm-hmm.
One is just installing the hardware, like the furnace, the boiler, the heat pump, whatever that part is.
Yeah,
The second part that often gets overlooked is the distribution system, all that ductwork. And if they didn't really do a great job sealing all the duct leak cracks, things that leak hot air out into your attic, out into the environment, it's not going into your house.
mm-hmm.
And that's very inefficient. That makes you spend more money than you should.
Mm-hmm.
So not just making the attic a hot attic, but also there's a company called Aero Seal. Aero Barrier would be another version, but Aero Seal would, from the inside out of your ductwork, essentially put a fog, like if you can imagine caulking, turning into a fog, and then it just finds all the cracks in your ductwork and seals it up. That would be first you test how leaky the duct is. You get a number. Then you can say, all right, I've got $1,000 to put towards this Aero Seal caulking. See how low that leakage number goes, and that's your improvement. I mean, you can decide, is it 5,000, is whatever the number is. But the tighter you can get that, the less leaky your duct system is, the less you're wasting your heat. That's a specialty niche of that weatherization that Massive probably can't help with. But the heat loan, I think you'd have to look into the details if they can or not. The other option would be to bring your ductwork inside your building envelope, like under your ceiling,
Yeah.
and put more insulation on the ceiling. Hopefully when Mass Save did that extra insulation for you, they did air sealing in my house, they used 40 cans. I mean, it was ridiculous. So they were a really impressive crew that did a great job. I just don't know if they did as high quality work at your house. So if you're concerned at all about the air sealing on that ceiling, it might actually make more sense to take that insulation off, do the air sealing right,
Mm-hmm.
and then put extra insulation on top. Hope I've answered your question.
Well, yeah, but I mean, if we wanted to replace that system, would there be, these units, would there be any other challenges for these units? I mean, I guess, you'd be really starting from scratch in the basement because there's nothing in there now, as far as.
Yeah, you're getting into like individual home details, so I think a site visit really
Yeah.
would be the place to start.
Yeah.
There's 4 kinds of heat pumps, whether it's the mini split kind, if that's the most cost effective versus all this other stuff I was talking about. You can take a look at the quotes and compare them.
It's interesting, we actually installed 2 mini splits downstairs because the house itself is only zoned, there's only one zone on the first and second floor, and there's another furnace actually in the basement that heats the basement. So we find that, you know, the heat, it gets blown down from the attic, but then rises in the second floor, because the thermostat is actually in the first floor. And it rises to the second floor, and it was like, you know, 10 or 15 degrees warmer on the second floor than it was in the first.
Okay, that's not good.
Well,
So,
maybe not.
one of the-
Probably 8.
yeah, one of the nice things about being able to do this again is you can micro zone. If you're thinking of, you know, one zone is one floor,
Yeah.
you have an opportunity to have zones like in the master bedroom, in the living room at separate temperatures, and, you know, there's ways to get much more local control than just one floor.
So the mini splits, though, actually, we put them on the first floor, and it's working pretty well. It keeps the thermostat temperature up. It's not as warm on the second floor.
Yeah, there's ways, there's more than, like, mini splits aren't the only way to get micro zoning.
Yeah.
You can do it several different ways, but we're getting in, like, for just your one house, it really, I think, needs a site visit to figure
Sure.
out what's going on.
Yeah.
Great presentation. Do you know if there's any state or federal laws for new construction that would mandate this type of heating and cooling?
Well, as far as state laws go, it depends on what the building codes are in your town, but most towns in Massachusetts use what's called the Stretch Energy Code, and that is being updated this July. So if you're going to be building a new house, that updated code would apply. And the updated code has requirements. The energy efficiency requirements are much tighter than they were in the past, and they actually require, if you're going to be using gas heating, you have to do an even more larger job of making it efficient so that you don't need to use much gas. Let's see, and the incentives through Mass Save are there to incentivize you to use an all-electric home rather than using gas.
Thank you.
One thing about building codes, they're the worst quality energy efficiency standard. Like, that's the bare minimum, like getting a D in school. So you can look at, you know, building codes from 1989, from 2021, 2024, whatever year you want, and that's a ridiculously low bar. What's a better bar? There's a bunch of different names, but there's better standards all over the place by the name of LEED, L-E-E-D, by the name of Passive House. And you look at a passive house building standard, and that might need a hairdryer's worth of electricity to heat it for the winter. It's just because the air sealing's done properly, the indoor air quality is much better, things that the building code doesn't even consider. So if you are planning for this new construction, I'd encourage you to look at not building codes, but better than building codes. Like Living Building Challenge is probably the most comprehensive. It's like flowers on a petal, and one of the petals is psychologically, like, does the experience of living here lift you up? There's a spiritual side to it, which is really bizarre to hear in a building code, but that's the Living Building Challenge, and it'll talk about water reclamation and other things beyond the shell of the building. But if you want to just focus on energy efficiency of the building, passive house is probably the best.
And I want to mention that the building codes mention how passive house, and that if you do meet the passive house standards, that satisfies the building code. But they have another standard that you can choose one or the other.
another interesting thing about new construction is many houses we expect to be built on site. They show up with 2x4s and things and make a house. A few decades ago, there was so-called manufactured housing, like a big truck is trailering what looks like a mobile home almost. Not talking about manufactured housing, but prefabricated housing, where they're building a high-efficiency wall structure in a factory, in a warehouse, with weather-controlled, environment, not out in the rain and snow and stuff. They can take 5 days to assemble, these walls that, might have windows and doors already installed and wiring and things, and yet still the end result after 5 days is a passive house. So look at, let me think, Unity Homes, Bensonwood Homes. If you just look prefabricated, then that'll lead you down a fast, high-quality, energy-efficient home too.
I guess what I'm wondering is like, so this is a problem like for communities, for, the country, for the world, right? So you would think like going forward, they would try and do the heating and cooling that way, and I didn't know if there was any laws like for the state or, the federal government that would go forward that way, since that's the way they should be going anyways,
Well, they're heading that direction, but they're a long way from being there. There are currently 9 towns in Massachusetts that do not allow new construction to use gas. So that is one example. But the building codes are updated every 3 years and have been improving as they go.
That's good.
One last question. How do you know if your little yard could possibly use geothermal, or if you have like bedrock back there?
So funny enough, bedrock's actually good. If you're trying to drill on Cape Cod or soil that's has a lot of clay or something that would fall in on itself when that 500-foot well is being drilled, you would have to pay extra for a liner that prevents that material from closing the hole you just made. When we drill geothermal holes, the first 20 feet of liner are included, and we're hoping to get to rock. And we can drill, slower through that than softer material, but we know that the hole isn't going to fall in on itself. So it won't be a problem as far as making the bedrock is actually a good thing. So you can ask for an evaluation, and depending on setbacks, like you have to be a certain distance from your property line. Each well, if you need multiple, most of the times you need multiple wells, they have to be 25 feet apart with one kind of drilling technology. There are significant advancements happening in the drilling space, and that'll shrink those distances by quite a bit. They're just not yet available. Maybe in a year or two we'll see something. And then also, if you happen to be in a highly populated, densely populated area like Framingham, take a look at the website heat.org. They're doing networked geothermal. So instead of having gas lines running through the street, you're going to have, geothermal water running through a loop that big buildings and small houses, they can all take the heating and cooling that they need. Funny enough, in the winter, a large office building with a lot of glass actually needs cooling in the winter. So they're sending heat into this network, and a house, which intuitively needs heat, can take that, and the efficiency gains are really impressive. So we're all spending less on electricity for that networked geothermal that gets better efficiencies than if each building has its own, own wells for itself.
And you can nominate your street for network geothermal on the heat website.
Okay, my name's Lauren, like I mentioned earlier. We're partnered with the town of North Andover as well as Groundwork Lawrence and a few other of the towns in the area. So I want to talk about two things. One thing that was mentioned earlier was actually saving money on your electricity. North Andover, has anybody heard of community power, community aggregations? Does that sound familiar? I see a couple people. Awesome. So one way to save money right away is to get signed up with that community aggregation. Massachusetts has a free market, so you can buy energy from a whole number of different companies, including National Grid, the utility company. The town has jumped in and has different rules basically about how they can buy energy, so they can sell it to us usually much cheaper than what National Grid can offer. And then there's third-party energy companies. And a lot of those third-party energy companies can have some pretty predatory practices. I know I get mail all the time. I've met people at BJ's, like they come out of the woodworks to sell you energy. And often those contracts, they'll start you at a low rate. Later on, they'll hike it up to something else. So be wary of that. And if you want to save money right away, I'd recommend jumping on that community aggregation program. I believe the rate's about 14 cents right now, whereas National Grid's is 18 cents. So you'd be saving money automatically. Second thing, question?
Do they do net metering in these programs as well?
Yes, that would be,
They do.
yeah, that would be something separate, I believe.
Well, it's directly, part of the program is if you generate more electricity in the summer, it's going into National Grid's network. And you continue to get the net metering credits that you would if you were working, if you were buying from National Grid.
Yeah, this electricity bill is made up of two parts. One is the supply, and the second is the distribution. And there's also like a $7 monthly fee just for being a customer. But we don't really care about that. So if somebody's saying, like, what's your supply rate? Let's say it's 15 cents. Well, your distribution rate also happens to be like 15 or 18 cents. So what I encourage all of you to do is take a look at your actual bill, take a look at how much you're paying from your checking account, take a look at the total kilowatt hours for the month, and do the math yourself. You have to manually calculate what we think is our rate, which is both the supply and distribution rate. And then you come up with, 15 for supply, 15 for distribution, it's 30 cents. That's what's really coming out of my checking account. But whenever you ask the utility company what's my rate, they only tell you the supply side. So it gets a little confusing. But yeah, there's net metering that just happens automatically regardless of who you pick for just the supply portion. There's about 40 companies to choose from.
And then the second thing I wanted to talk about, the speakers mentioned that one of the first steps to getting started with electrifying your home, specifically with heat pumps, is weatherization. And so that's something that MassSave has really huge benefits for. No matter who you are, what your income looks like, you're getting a no-cost energy assessment that you can sign up for where they'll check out your home, and you're getting no-cost air sealing. So sealing up those gaps, maybe you can feel the draft coming through your windows, maybe it's something they have to use a sensor for, but they can seal up those cracks. And then they're able to do insulation, and that, depending on your income, can be anywhere from 70% off to completely no cost. So I would definitely recommend, if you're thinking about this, that can be a really good first step. Some people also mentioned that they had already gotten that done, had already gotten some installations. Even if you've done it, you're eligible every 2 years. So if it's been a while, I can help you get signed up for another one. You can come talk to me, and I'm happy to answer any questions or help you get signed up.
I'm just going to mention, I think in North Andover, you're part of the town's community aggregation unless you opt out. I think. I'm not sure.
Yeah, that's true. You're opted in if your rate was originally with National Grid. If you had a third-party energy company, you have to actually opt in. But otherwise, you're right. If you have the regular national grid rate, you're automatically opted in unless you told them no thank you. Then you're opted out.
With the North Andover supplies, is that automatically 100% renewable, or do they start you off with something less and then you have to choose the 100%?
Yeah, there's a few options. There's a standard rate, which I think is a little bit above what Massachusetts requires. Otherwise, you can opt up to a more renewable option, or you can opt down to basic, which is the cheapest and meets Massachusetts state requirements exactly. So depending on what you're looking for as far as budget, there are a few options.
Well, thank you for this great presentation. This has been really informative. I'm sure it has for everybody who's been here this evening. Thank you, Chris, and thank you, Gary. Hopefully you'll take this great advice and make the right decisions moving forward. Thanks for everybody for coming. Have a great evening.